Hey guys, so we're coming off of simplifying rational expressions and multiplying rational expressions, and today we are ready to tackle the third lesson in this chapter called dividing rational expressions. Good news is it's a very small step up compared to what we've seen. A lot of it comes back to how good are we at factoring and recognizing what's allowed to be canceled versus what's not allowed to be canceled. And if you felt comfortable with those two ideas before, then you're going to really crush this lesson as well. So what we're going to see in the video here today is, we're going to take one rational expression like this that's got monomials and divide it by another one. And then, of course, we're going to graduate from monomials up to, binomials and trinomials. So you'll see something like this rational expression divided by this one. So very similar to yesterday, we're just replacing the multiplication sign with a division sign. And we're going to take a look and see how that affects it. So a couple of, just vocab words, I guess, that we want to be really comfortable with. So the definition of a factor is basically any polynomial that is separated from another polynomial by a multiplication sign. So we want to really emphasize multiplication there. Compare that to this definition. What is a term? Well, a term is when one polynomial is separated from another polynomial using either a plus or minus sign. Now you're thinking, well, what's the big deal? That really doesn't seem like a big deal. But here's where it all comes down to. We are allowed to cancel factors, but we're not allowed to cancel terms. And hopefully that's going to help us, decide what's legal to cancel and what's not. So recall just a real basic example here. Let's imagine that we had 2x squared minus 10x all over, maybe 3x squared plus 12x. So if you were going to just simplify this expression, just simplify it, that's your only goal. We're going to go ahead and take out a GCF of 2x, leaving us with x minus 5. We're going to go ahead and take out a GCF of 3x, leaving us with x plus 4. And what we're going to do here is I can cancel this x with this x because each of those are factors because we have the implied multiplication signs here, here, and so the x's were a factor. So when you're all done with this one, your final answer, whoa, what just happened on me here? Let's try this, see if this works. So your final answer is going to be 2 times the quantity x minus 5 all over 3 times the quantity x plus 4. And you're wondering, why in the world am I allowed to cancel these x's here, but all of a sudden I'm not allowed to cancel these x's? Well, the simple answer is this x right here is just a single term because it's separated from the 5 with a minus sign. Same thing here. That x is just a term and we're not allowed to cancel terms. Okay, so as we're revving things up for today's lesson specifically, so when you see a fraction, and let's just think of a general sense, let's say we have a divided by b, and that's getting divided by c divided by d. Okay, so the very first fraction you see, that a divided by b, that one's called the dividend. And then the second fraction you see, in this case, c divided by d, is called the divisor. So our game plan today is if you want to divide two fractions, all we really do is just multiply the dividend, or the first one, by the reciprocal of the second one. So we have this really goofy little saying, and it's called keep, change, flip. All right, keep, change, flip. Now, what in the world does that mean? Keep, change, flip. Well, basically it says keep the dividend exactly the way you see it, a divided by b. And then what we're going to do is we're going to change the operation from division to multiplication. And then the flip stands for reciprocating the divisor. So you'll get d on top now divided by c. And then you just multiply across just like we did yesterday. And then you get AD divided by BC. And that would be our final answer in that case. Let's tackle like one really simple example that we might have seen in middle school or whatnot. Let's say we had 6/8 divided by maybe 21 over 20. So the first thing we're going to do is we're going to do a keep, change, flip. And then we're just going to get everything factored. Okay, so that 6 can be rewritten as 2 times 3. Those are his factors. 8, the factors of 8 are 2 times 4. The 20 could be 4 times 5. And then really that 4 is 2 times 2. So we get 2 times 2 times 5. Now the 21, I'm thinking, is 3 times 7. Once you get this broken down into all the factors, of course, we could start canceling. Boom, boom, boom. Let's see. Oh, I didn't break that 4 down. That 4 should have been a 2 times a 2. I didn't even catch that. So those are both going to cancel with these two. And at the end of the day, you're just left with a 5 over a 7, and that's your simplest answer. Now, of course, if I gave you that same problem today, you'd probably be able to skip almost all of that work just about and be able to do it much quicker. But we want to kind of talk about what's going on behind the scenes, so to speak. One last little nuance before we dive in. We're going to talk about the constraints or the restrictions that we have to put on the domain to ensure that we're not dividing by 0. That's the word that's hiding there, to ensure we do not divide by 0. So in this particular case, each individual fraction in itself can't be divided by 0. So in essence, this b value right here cannot be 0, and this d value cannot be 0. So those are the first two obvious ones to me anyway. B cannot be 0. D itself cannot be 0. The other one that's a little less obvious is another way to write this problem is to stack them vertically, like where you say A divided by B divided by C divided by D, right? And then in this particular case, when you think about it, this fraction as a whole can't be equal to 0, because otherwise then you're taking the top fraction and dividing it by a big 0. And the only way that bottom fraction could be 0 is if C itself was 0. So we'll say C cannot be 0. So really the only thing that's allowed to be 0 is that first little a. Other than that, the other three corners, so to speak, cannot be 0. All right, let's dive in. Okay, so how are we going to factor? These are just monomials, and we handle them a little differently than we might handle a binomial or a trinomial, etc. So this 3x to the 4th, I just like to break it down into 3 times x times x times x times x. That's my preference. The 6 is going to be 2 times 3. Okay, I'm going to change this division sign into multiplication. So now the 10's on top, right? Now the 10's on top, so that's going to be 2 times 5. And the 9x squared is going to go on the bottom, so that's going to go 3 times x times x. And now here comes the super fun part. We're just going to start canceling whatever we think we can cancel. This x with this x, this x with this x, maybe this 2 with this 2. And so when it's all said and done, on the top, I've got to multiply this x times this 5 to get 5x squared. And on the bottom, I got to multiply this 3 and this 3 to make a 9. And that's our final answer. So that's monomials. Now we're ready to graduate into some binomials and trinomials. And not every binomial per se is guaranteed to be factorable. But of course, if it is factorable, we got to jump on it. If there's a GCF, we got to jump on it. If there's a difference of 2 squares, we got to jump on it. And the first thing I noticed here, and I think might as well just take a nice little baby step on this one here, is let's just practice keep, change, flip, and nothing else. So let's keep the dividend the same. All right, that's our keep. We're going to change that division into multiplication, and then we're going to flip the divisor. Okay. And now at this stage of the game, we're right back to where we were yesterday. And we said, okay, let's multiply everything on top and just really get this expressed as just one big fraction. And then from here, we can just work on factoring those completely. So like, for instance, this x squared plus x minus 6, we got trinomial. So I'm looking for two numbers that multiply to -6 and add up to 1, which is going to give me, I believe that's x plus 3, x minus 2. And then we'll just rewrite that x minus 5 because it can't be factored any further than it already is. All right, on the bottom here, we need two numbers that multiply to -10 and add up to 3. So what numbers are going to get the job done for us here? I'm picturing x plus 5. I'm picturing x minus 2. And then we'll just rewrite that x plus 3 because it can't be factored any further than it already is. And let the fun begin. So we've got, and again, these are all factors because they're separated by multiplication signs. And so you can cancel this factor with this factor. We can cancel this factor with this one. And then, but that's all I can cancel. So my final answer is going to be x minus 5 divided by x plus 5. And boom, that's my final answer. Now, the restraints that we were talking about earlier, okay, if you go back to those, remember how we basically said this cannot be 0, this can't be 0, and then basically this can't be 0 either. So those are the three things you need to consider. So right up in that top right corner, we could say x cannot equal -3. In the bottom right-hand corner, we could say x cannot equal 5. And then this one's a little bit trickier. You want to look at the factored version, right? Remember how that one factored into x plus 5 and x minus 2? So you want to say x cannot equal -5 and x cannot equal 2. So there would be those four restrictions attached to this answer at the end. And a lot of times they're going to ask you for one or the other. They'll just ask you, what's the simplest answer here, or what are the constraints or restrictions that we'd have in the sense of what x is not allowed to equal. Okay. I think we got one more bear cooking for us here today. Same idea. Let's just take it nice and slow. And we're going to go keep, change, flip, and nothing else. So we're keeping the first one. We're changing our operation. And then we're flipping the divisor here. All right. And then we'll just go ahead and multiply across to express it as one big fraction. And we're going to have a lot of fun trying to factor this here in a few minutes. Okay, the first thing I noticed, and I think you'll feel more and more comfortable with this with experience, is this 7 minus x is out of whack, isn't it? We're expecting typically the variable first and then the constant, which is the 7 here, coming second. So what we're going to do is we're going to use that trick where we factor out a -1. And so I'm going to factor out the -1, and then the x becomes positive and the 7 becomes negative. Okay, now what are we going to do with 2x plus 4? I think we're going to factor out a GCF of 2, okay? Let's see. With this x squared minus 4, we got ourselves a real traditional difference of two perfect squares. And then let's see. What adds up to -7 and multiplies to -6? I'm picturing x minus 7 and x plus 1. So now we're completely factored, and we can just let the good times roll here. We're going to cancel the x minus 7s. What else? We could cancel the x plus 2. That's really nice. And I think that's about it. So if we just kind of tidy this one up, I'm thinking -2, because I had to multiply this -1 and this 2. And then we've got the x minus 2 and the x plus 1 on the bottom. We'll wrap that bear up. Now, as far as what are our constraints, all right, what are our constraints? Or another word for constraints is restrictions here. So we're going to go back up and we're going to look at, whoopsie daisy, I need to move it there. Okay. So basically we're saying, remember, this guy can't equal 0. This one cannot equal 0, and this one cannot equal 0. So if you consider their factored forms, I'll start with the x squared minus 4. That was factored right here. So we could say x cannot equal +2, x cannot equal -2, all right? The next one here is maybe that x squared minus 6x minus 7, which got factored right here. And we could say x cannot equal 7, x cannot equal -1. And then last but not least, let's think about 2x plus 4, which factored right here, which we'd end up saying x cannot equal -2, but that's just repeating one that was already mentioned, so we don't have to like restate it. So that's all there is to dividing these rational expressions. So we're going to feel like our big goals here are, do we feel good about factoring, and do we feel good about, what I'm allowed to cancel versus I'm not allowed to cancel? The only real new idea today is the idea of keep, change, and flip, and I think that's pretty straightforward. So, hey, good luck tomorrow, guys. We'll see you.